Every atom of iron in your blood was forged inside a dying star, and when that star could make no more iron, it exploded. Not metaphorically, literally. The iron running through your veins right now was produced in a stellar core, ejected across light years of space, and eventually pulled into the cloud of gas and dust that became our solar system. And iron did not just happen to end up here. Iron is the reason those stars died. By the end of this video, you will know why iron is the most dangerous element in the universe, not because of what it does to you, but because of what it does to stars. Right arrow the exact moment in 1987 when scientists watched a star die in real time and confirmed, for the first time, that iron is the reason supernovae happen. And why the Roman Empire's iron weapons were cosmically inferior to the swords their enemies were carrying, because those enemies were using iron that fell from the sky. And you will never look at a piece of steel or a drop of blood the same way again. 3,000 years ago, in the shadow of the Hittite Empire, a blacksmith was working metal that no one else in the ancient world knew how to make. The Hittites of Anatolia, modern-day Turkey, had cracked something extraordinary. Around 1400 BCE, they had mastered iron smelting, not just working iron, smelting it, extracting it from ore, and they guarded that knowledge the way we guard nuclear codes. To their neighbors, iron objects were sacred. The Egyptians called it the metal of heaven. In the tomb of Tutankhamun, among all the gold and lapis lazuli, archaeologists found a single iron dagger. Analysis in 2016 confirmed it was made from meteoritic iron that had literally fallen from the sky. It was more valuable than the gold surrounding it. The ancient Greeks believed iron was a gift from the god Hephaestus, the divine smith who worked his forge beneath volcanoes. The Norse thought it came from the blood of giants. Every ancient culture that encountered iron understood on some instinctive level that this material was different, that it came from somewhere else, that it was not of this earth. They were wrong about the gods, but they were right that it came from the stars. To understand where iron comes from, you need to understand what stars actually are, because most people have a piece of this wrong. A star is not burning, not in the way a candle burns. A star is a nuclear fusion reactor, constantly crushing hydrogen atoms together to form helium, releasing energy in the process. That energy pushes outward, gravity pulls inward. The star is a permanent war between those two forces. As long as fusion produces energy, as long as the outward push is bigger than zero, gravity cannot win. The star holds its shape. Now here is where it gets extraordinary. As a massive star ages over millions of years, it exhausts its hydrogen and begins fusing helium into carbon, then carbon into oxygen, oxygen into neon. Neon into silicon. Each step releases less energy, each step shortens the star's life. Think of it like a campfire being fed progressively worse wood. First dry oak blazing, then damp pines struggling, then wet leaves barely lit. But silicon fusion produces something different. It produces iron. And here is the wall. Iron atomic number 26 element Fe is the most stable nucleus in the universe. Physicists call this the peak of the binding energy curve. What that means in plain language is this: you cannot get energy out of iron by fusing it. You cannot get energy out of iron by splitting it. Iron simply absorbs energy. It is a nuclear dead end. When a massive star begins fusing silicon into iron, it is spending its last reserves. The iron builds up in the core. It does not react, it just accumulates. Within a matter of days, sometimes hours, the iron core reaches a critical mass. About 1.4 times the mass of our sun, compressed into a sphere roughly the size of a city. And then gravity wins. The core collapses in less than a second. The outer layers of the star, which have nowhere to go, slam into the collapsing core and rebound in one of the most violent events in the universe, a core collapse supernova. The explosion releases more energy in 10 seconds than our sun will release in its entire 10 billion year lifetime. But here is what most people miss. Most of the iron you have ever seen was not made in that explosion. It was made in the core over thousands of years before the explosion. The supernova's job is not to make iron. Its job is to throw iron into space. The iron in your blood is older than the explosion that freed it. For most of human history, all of this was theory, elegant mathematics, beautiful models, but no one had ever watched a star collapse in real time. Until February 23, 1987, 7:35 a.m. Universal Time. In the southern sky, in a galaxy called the Large Magellanic Cloud, a satellite galaxy of our own Milky Way, 168,000 light-years away, a star called Sanjalik -69 degrees 202 collapsed and exploded. The light arrived on Earth at 7:35 a.m., but before the light, something else arrived. Neutrinos. When a stellar core collapses, it releases an almost unimaginable flood of neutrinos, subatomic particles that barely interact with anything. They travel at nearly the speed of light. They pass through matter as if it isn't there. 3 separate neutrino detectors around the world registered a burst of 25 neutrinos within a 13-second window. The Kamiokan Day 2 detector in Japan, the Irvine, Michigan Brookhaven detector in the United States, the Baksan Neutrino Observatory in Russia. 25 particles out of the 10 to the power of 58 neutrinos that were released, and they confirmed everything. The core had collapsed, a neutron star had formed, the supernova was real. The event was named SN 1987. It was the brightest supernova visible from Earth since 1604, when Johannes Kepler watched another star die before telescopes existed. The detailed observations were published by Hirata et al. In Physical Review Letters in 1987, and by Bionta et al. In the same journal the same year. Both papers described the same 13 seconds that confirmed a century of theoretical physics in real time. Astronomers turned every instrument available toward that patch of sky, and in the gas clouds expanding from SN 1987A, they detected exactly what the models predicted: iron, radioactive nickel-56 decaying into cobalt-56 decaying into iron-56. The fingerprint was unmistakable. 168,000 years ago, a star died and scattered iron across its galaxy. We watched the light from that death arrive on a Tuesday morning in 1987. Here is the fact that even people who know the supernova story usually get wrong. Our sun cannot make iron. This sounds obvious once you hear it, but consider what it means. Our sun is a perfectly ordinary middle-aged star. It will fuse hydrogen for another 5 billion years, then helium. Then, because it is not massive enough, it will stop at carbon and oxygen. It will puff into a red giant, shed its outer layers, and leave behind a cooling white dwarf. No iron, not a single nucleus of iron, will be created by our sun in its entire existence. Every atom of iron on Earth, in our oceans, in our mountains, in the molten core that generates our magnetic field and protects us from radiation, in the haemoglobin carrying oxygen to your brain right now, came from stars that died before our sun was born. Our solar system is made of the ash of dead stars. This is not a metaphor, this is the chemistry. The iron in Earth's core is so abundant, roughly 32% of the planet's total mass, that it generates a magnetic field extending tens of thousands of kilometers into space. That field deflects the solar wind. Without it, our atmosphere would have been stripped away billions of years ago, the same way Mars lost its atmosphere after its core cooled and its magnetic field died. The iron from a dead star is the reason Earth still has an atmosphere. The iron from a dead star is the reason you can breathe. That is not a small thing to sit with. Let us come back to Earth, because the history of iron is also the history of power, and it is messier than the cosmic story. The transition from bronze to iron, the Iron Age, that historians date from roughly 1200 BCE, was not a smooth technological upgrade. It was triggered by collapse. Around 1200 BCE, the Bronze Age civilizations of the Eastern Mediterranean, the Mycenaeans, the Hittites, the Egyptians, the Canaanites, collapsed within decades of each other. Historians call it the Late Bronze Age collapse, and its causes are still debated: drought, migration, internal rebellions, disrupted trade routes. Possibly all of them at once. When those trade networks collapsed, the supply of tin, essential for making bronze, dried up. Societies that had built their military power on bronze weapons suddenly had no bronze. Iron was the emergency substitute. It was everywhere. You could smelt it locally. You did not need trade routes to Cyprus for copper or to Afghanistan for tin. Any society with wood, fire, and iron ore could make weapons. Within 2 centuries, iron had replaced bronze across the entire ancient world. Not because it was obviously superior. Early iron was actually softer than good bronze, but because it was available to everyone. The democratization of iron changed warfare, agriculture, and empire. Iron plows broke soil that wooden plows could not. Iron axes cleared forests. Iron nails built the ships that carried Greek colonies across the Mediterranean. And those Roman legions, with their iron gladii, their short stabbing swords, who conquered most of the known world. They were fighting, in some cases, against enemies carrying weapons made from a different kind of iron entirely. Meteoritic iron, iron that had fallen from the sky. Swords from the Siberian steppes, the Persian highlands, the forests of Germania. Some of these were forged from iron meteorites, which contain a natural nickel-iron alloy that when worked correctly produces blades with exceptional hardness and a distinctive crystalline pattern called a Widmanstätten pattern, visible only when the metal is cut and etched. These were literally star metal swords, and their owners knew it. The supreme irony is this. The Roman Empire, which prided itself on its superior technology and engineering, was conquering territories where the local smiths were working with material that had already crossed interstellar space. The legionaries with the most advanced military machine in the ancient world were sometimes outclassed, blade for blade, by warriors using metal that fell from the sky. Cosmic origin did not care about empire. The next time you cut your finger and see blood well up, red because of iron, specifically because of the iron atom at the center of each haemoglobin molecule that holds an oxygen atom and carries it to every cell in your body, consider what you are actually looking at. That iron was made in a star that no longer exists, in a galaxy that was old before our sun ignited, in a nuclear process that took thousands of years, and ended in an explosion visible halfway across the universe. It traveled through space for millions of years. It was pulled into the accretion disk that became our solar system. It sank into the molten Earth. It was pushed back to the surface by volcanic forces over billions of years. It was absorbed by plants, eaten by animals, and eventually, through a chain of biology so long it disappears into deep time, it ended up inside you. The iron in your blood is not a chemical coincidence. It is the most traveled thing you will ever own.